Hi there. In this video, we are going through my introduction into exponents. This video is going to have the rules and properties of them that I will then go over more in depth and prove, or at least show why they work in other videos. Those videos will be linked in the description. But just to show what the properties and rules are, here we go. Quick overview. We've got the power rule, the quotient rule. I messed that up. I'm sorry. This is the product rule because it's the product of two things. Quotient, and then this is the power rule. And then these are similar, or at least they look similar to the product and quotient rule, so I am going to be going over them as well. Then, as with a lot of things, ones and zeros have some interesting properties with exponents. If the exponent is a zero, so a to the 0 power, it always equals 1, no matter what a is, no matter what the number being brought to the 0 power is, except 0 itself. 0 is completely undefined. Then to the 1 power just becomes itself, so anything to the first power is itself. Then other special categories, if you want to call them that. Negative exponents, which make them 1 over whatever the original was, so the negative goes away when it's in the denominator here. Got fractional exponents, so just easy cases, 1 over something becomes so 1 over y, it becomes the y root of it. So it's always whatever the denominator is, that's the root. If it is a more complex fraction with a numerator and denominator, and the numerator's in just 1, and it does kind of work here too, because that's 1, and here you can see the x becomes an exponent inside of the root. So here the 1 is there, but we don't have to write it because anything to the 1 power is just itself. So whatever's in the denominator is always the root. So the y root of a to the x power. Now if they're combined, you do both things. So a to the negative x over y power. That becomes 1 over the yth root of a to the x. So we'll be going into more detail with each of those with the videos in the description. But this is an intro to exponents, so I'm going to show you how I'm going to be another way of writing exponents that I am going to use to help prove the different aspects. So, exponents are multiplying repeatedly. A times a times a times a. So, a squared means we're going to have 1a times 2a's. If it's a cubed, that means we're going to have 1a times 2a times 3a's. So what if we want to make a notation where we're just going to say we're going to keep going on and on and on? So let's label that as a to the x power, like up here. So to write that in more in-depth I can speak well. That's 1a, because there's always going to be at least 1 unless x is 0, times 2a times, and then this is a notation that is very common throughout math, so this is a good way to introduce it at least. Dot, 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 3 dots, or an ellipsis. If you see this, it means it continues up until, so 1, 2, this signifies 3, 4, 5, however high we're going, and we're going to say we're going to the number x, which we don't know what it is, but we're going to keep going up by 1 and 1 and 1 and 1 and 1 until we get there. So hopefully you can see how this can turn into here, and we're going to be using this, so at least for my videos, you're going to want to know this for sure. And it's just good to know this 3-dot notation, the ellipses. So definitely know that, and then just know this is another way I am going to use it to prove the rules and the properties down here. Hopefully this was an okay introduction. not much to go over because it's a simple concept, just multiplying over and over again. Yeah, so click down below for any of the rules or properties, and I hope any of them help. See you in the next video.